Example 3. Designing a front door for a home using table A2. When designing equipment, one common criterion is to use a design that accommodates at least 95% of the population. What is the height of a door that would allow 95% of adults to walk through the doorway without bending or hitting their heads? Now, based on data set 1, which is body data in Appendix B, assume that heights of adults are normally distributed with a mean of 66.2 inches and a standard deviation of 3.8 inches. How does the result compare to the door height of 80 inches required by the International Residential Code? So in this problem, we want to first draw our bell curve so that we can see what we're looking for. So it's always important to draw your picture. Okay, so we know that the mean is given to be 66.2, so we're going to label that as 66.2. Now in this problem, we're given the fact that it says that 95% of the population of adults, we want to find out what is the height of that. So what they're saying here is that if we shade 95% of that curve, so let's go ahead and shade 95% of that. So if we shade 95%, then this is going to represent that area of 95%. So we're given the fact that this area is 95%. So let's go ahead and then write that in here. So we know that 95% is the same thing as 0.9500, which represents that area. And so what we're looking for is what is this x value. So we need to find out what is that x value. Now, we also are going to have to use our table for z-scores. So we know that the mean for z-scores is always 0, and we need to determine what is that z-score according to the area of 95%. So, again, we drew the normal curve. We shaded the desired area of at least 95%, which is 0.9500. And remember, at least means the area to the left, which is 0.9500. And the shaded area represents the shortest 95% of adults. So the drawing shows a normal distribution with the height x that we want to identify, which is what we want to find. So when using the formula, x is equal to the mean plus z times the standard deviation, we want to first determine the z-score so we can plug it into this equation to solve for x. So using table A2, we want to search for an area of 0.9500 in the body of the table. So if we take a look here, it's going to be in between these two values here. Okay. Now, it says here the area of 0.9500 shown in the figure is a cumulative area from the left. So the area of 0.9500 is between the table of A2 areas of 0.9495 and 9.9505, which is an asterisk and a footnote indicating that an area of 0.9500 corresponds to a z-score of 1.645. Okay, so another way of saying that is that since that 0.9500 is equally distanced between those two, we would then take the average of the following. So we know that we have 6.4 and then we have 1.65. So to find that z-score, we would say 1.64 plus 1.65 and divide that by 2, which would give us 1.645. So therefore, that is the z-score that we get, 1.645. So knowing the fact that we have the z-score now of 1.645, the mean of 66.2 inches, and the standard deviation of 3.8 inches, the result of x can be found directly or by using the following version of the conversion formula. So here we have x, which is equal to the mean, which is 66.2, plus the z-score that we just found of 1.645, times the standard deviation of 3.8. So we multiply these two together and then add 66.2, and we get a value of 72.451. So we want to round that to one decimal place, so we would say the solution of x, which is equal to 72.5 inches, is reasonable because it is greater than the mean of 66.2 inches. So that means over here now we can say that x is now the value of 72.5. Okay, so now let's take a look at the second part of the question. It says, how does the result compare to the door height of 80 inches required by the International Residential Code? Well, here's our interpretation. A door height of 72.5 inches would allow 95% of adults to walk through without bending or hitting their heads. The door height of 72.5 inches is well below the height of 80 inches required by the International Residential Code, so more than 95% of adults could walk through doors meeting this requirement without bending or hitting their heads.